So initially the piston, so here pressure P0, V0, T0, P0, V0, T0, gamma 1.5. Insulated cylinder it is. The piston is also insulated, non-conducting. Now the external agent, is going to shift the piston slowly. The piston divides the cylinder in the ratio 1:3. So I will definitely, I think the position of piston should be somewhere like this. I think this much is the question. What is work done by external agent? So what process the gas? The external agent will slowly move. So here we have to show it. External agent will come into picture here. Or F external is what you can show it. Okay, this is the question. What we have, P0, V0, insulated. Yeah. Read the question. He's asking now the work done by external agent. Okay, now slowly the external agent will move it. It will slowly move such that the ratio of volumes will become 1:3. So if this is V1, this is V2. So what we can write? V2 by V1 as 1:3. What process the gas will undergo in each part? Any heat supplied? No. Pressure varies, volume varies, temperature varies. So there is no heat exchange. So therefore adiabatic process. What about here? Here also adiabatic process. See, external agent can move a piston. I discussed work done by external agent is plus delta U. Work done by gas minus delta U. That is the idea of this one. So external agent in fact will move, can displace a piston. So here the gas will undergo adiabatic process. So here we'll write it here. Okay, now I think it's very clear. We know ratio of volumes. So now V1 plus V2 should be equal to 2V0. V1 equal to 3V2 plus V2 equal to 2V0. So therefore, what is V2 equal to? V0 by 2. What is V1? 3V0 by 2. Okay, these are about the V1 and V2, we know it. Can you calculate the final temperature? Okay, this will be in the left part. P0, okay, temperature is needed, no? So therefore I'll go for T0, V0, gamma minus 1, T1, V1, gamma minus 1. Gamma is 1.5, 1. So 1 by 2 it is. So we want a temperature. So T1 equal to T0. Anybody T1? Under root 2 by
Sir?
3.
Sir, why did you write 1 by gamma minus 1, sir?
Oh, I didn't. I should not do like that. Huh? Yeah. Okay, ma. Gamma is 1/5. I think it will be how much? Under root of 2/3. Similarly, what is T2 in the right part? Root 2 T naught. Okay, now it's asking work done by extringent. Okay, fine. Something adiabatic process, something I applied it. How to bring work done by extringent? Work done by extringent, what is the formula? Work done by external agent should be equal to plus delta U, no? So therefore this will be delta U1 plus delta U2. What is delta U1? Number of moles R by gamma minus 1 T1 minus T naught. Number of moles NR gamma minus 1 T2 minus T naught. I think substituting this will get work done by extringent. I have answered. I'll write it here. You do later on you check it. In terms of P naught, V naught, I brought it. Okay, slowly extringent moves. Okay, if it displaces, then there's a method what we can apply it. There's a find the heat capacity. So there's a gas we have, ideal gas. No. So he's asking no, there's a piston. No much information is available. Huh? You can see the question. Natural length, the length of the cylinder and natural length of the spring is L. So what is the total length of the cylinder is L. Divides into two equal parts. So initially it is L by 2 and L by 2. Find the heat capacity of the gas. Huh? He's asking molar heat capacity. How some spring comes can we determine? I think these are the some. Okay, read carefully. So what you can do it now. So what is the length of the spring? Natural length of spring is L. So initially what is the state of spring? Compressed, no? It is. It's a monoatomic ideal gas. Mono, I'll write it. No. So I'll slightly displace it. Let me displace it here. If I slightly displace it, then additional spring force will act. Or initially what happens, there'll be some pressure of gas here. So call that as say like a P naught, whatever you want, you can write it. Let the pressure of gas be P naught. So initially spring will be compressed. So spring force Kx naught, pressure force of gas, let it be P naught S. Now I'll slightly displace it. If I slightly displace it, I'll supply, or you can say I'll supplied heat, then the gas has expanded, then the spring got compressed, a spring force will act here now. So K x naught plus x, and this will be P plus P naught into S. Pressure got incremented. So this will be a lot of confusion. So what I suggest is like a directly, don't write anything here. Let it be here. So here, let X be the compression of spring. Pressure force of gas and spring force. Still it's a vacuum. This is a monoatomic ideal gas. No, don't do, you can, it'll be very lengthy. I feel like, I know there is some, initially some compression is there, there'll be some pressure of gas. I supplied heat, then the gas will expand. Volume will increase, pressure will increase, temperature will increase. Then it has come to slowly it is, not sudden. It has come to this position. He's asking molar heat capacity. So what is this PS now? The pressure force of gas will balance the spring force. So this pressure is equal to what? nRT by V into S equal to Kx. So therefore, what is a new volume of gas? nRT AX. Okay, this is, I think, S, I'll write it. S get cancelled. So therefore, nRT by K equal to X square. So we know change in temperature of the gas, and also we know increase in elastic potential of spring. So now what all heat supplied to the gas? Let's get into the concept. What happened? A part of energy is utilized to increase the intensity of gas. Remaining what happened? Work done by the gas. What is work done by gas? Anybody? That work done by gas is what? It is utilized to compress the spring, to increase the elastic potential of spring. If spring is not there, free expansion again. Getting the idea? Piston is massless, insulating piston and light piston. A light insulating piston. Okay, somebody is asking. Okay, no. So there won't be any kinetic energy. So therefore, what is work done by gas? Work done by gas is nothing but increase in elastic potential. Sir, how do you can say that? So you have your own equation. Work done equal to integral of P dV. So work done by gas, let me put it separately. Integral of P dV. This is PS into dx. So what is PS into kx? So this one, let it be here. So
Sir,
K, let me finish off, then you can get into the discussion. Similarly, the temperature of gas has increased. So therefore now, so what we have to calculate is like a molar heat capacity. How to bring molar heat capacity means we have only formula C equal to Q and delta T. On supplying it, temperature of gas will increase. Gas also does work. So here Q is equal to now delta U, work done by the gas. What is delta U? N 3R by 2 T2 minus T1. Work done by the gas. K by 2 x2 square minus x. What to do with x2 minus x1? That's what I have equation here. So K x2 square, what we can write it as? Okay, 1 by 2 I'll keep as it is. So this will be nR T2 nR T1.
Well, the length of left part of cylinder should be L by 2 plus X. No, sir.
No, I just assumed x mark. Don't go for lengthy calculation. I just, okay, this will become now, everything will become 2nR. Okay, what is molar capacity? Q by N delta T. So what is Q? 2nR T2 minus T1 by N You can do one thing. See, you do one thing, L by 2 plus X, again get expression for pressure as a function of X, then solve all, you'll get it. So there's one more easier method. Let me measure that X, everything here.
Sir,
Uh,
sir, but the force should be K into change in length now, sir.
no. See, we are supplying heat and the gas will undergo expansion and the spring will undergo compressions.
Sir, that compression will not be X now, sir. It will be L by 2 minus X now, sir.
No, that one.
Minus
See,
L by 2.
so what I'm telling is let X be the distance I'll measure from there. So therefore the same X is what I used here. You can try to see here. You solve by your method, you'll get same answer. Then you feel, okay, this is the easiest way of thinking. I know you want to say L by 2 plus X and solve it again, solve it. No, it'll be very lengthy calculations, but you'll get same answer.
No,
Just
sir.
simplified here.
In this method only, K into X minus L by 2, sir. Because change in length is X minus L by 2. No, sir.
Similarly, what is the pressure? Pressure should be initial, no? Initial pressure plus why you're not thinking in that way here. So that initial pressure force and initial spring force will get eliminated. If you want to think in that way. Huh? You're thinking only this. Why you're not thinking about this? There's some initial pressure also there, no? Initial pressure force will balance initial spring force. When I supply it, the additional pressure force should balance additional spring force. Finish over. Go back to Spring's ideas. Okay, yeah? Okay, I think we have time. This is. Or whatever you're thinking, no, you can try that, no problem. You'll get the same answer. I'll read the question. So we have some sort